The type of copper cables you use on your network is important, but also the termination of those cables is important. That's why before implementing a new network, it's always good to grab a cable tester and make sure that all of your cables have been terminated correctly. These cable testers are relatively inexpensive, and they can quickly show you exactly the way the cable is mapped from one end of the connector to the other end. And if you're not familiar with running cables and terminating the ends, you may want to look into getting a professional who really knows the nuances of making your cable installation work perfectly. Like most things in networking, there's a standard for terminating cables. You can, of course, look at the EIA-TIA 568B standard that shows you exactly how to terminate 8-conductor 100-ohm balanced twisted pair cabling, which is exactly the cabling we use on today's networks. You have the choice of two different standards when you're terminating copper cables. One is the T568A, and the other is the T568B. These are two different termination standards, so you would usually pick the one that you'd like to use and stay with that termination standard throughout the installation of your cables. Some people will use certain types of pinouts depending on how they're running these cables. For example, if you're running cables on a single floor, some people prefer to use T568A as the pinout for all your horizontal cabling. But some organizations prefer using 568B. It really doesn't matter which one you use as long as you stay consistent. You do not want to terminate one end of a cable with 568A and the other end with 568B. You will run into problems, especially on a gigabit network. If we were to look at all of the different pins inside of an RJ45 connector, if we look at this from the bottom of the connector, those pins are numbered 1 through 8. Each one of these standards uses slightly different pinouts. You can see on the 568A standard, pin 1 is white and green, and pin 2 is green. You can see on the 568B standard, it's white and orange for pins 1 and 2. So notice the green and the orange are different between the 568A and the 568B. Fortunately, pins 4 and 5, which are blue and white and blue, and pins 7 and 8, which are white and brown, are identical between 568A and 568B. You should be able to look at the bottom of an RJ45 connector and see exactly how it happens to be terminated. You can see we've got white, orange, white, green, a blue, a white, blue, a green, a white, brown, and a brown. So this would be a 568B termination. And on the other end of a straight through cable, we want to be sure that we're also terminating it with 568B. If we're connecting a workstation to a switch, then we're usually using a straight through cable. This is where pin 1 is connected to pin 1, pin 2 is connected to pin 2, pin 3 to pin 3, and so on, all the way through pin 8. This is also called a patch cable, and it's one of the most common Ethernet cables you run into. If you have Ethernet cables connecting your equipment and you disconnect those and look at the ends, you'll see that all of the pins are connecting straight through from one side to the other. If we need a straight-through cable for 10 base T, which is a 10 megabit Ethernet network, or 100 base T, which is a 100 megabit Ethernet network, this straight-through cable only needs 2 pairs. So there's 4 wires inside of the cable that are used for these specific Ethernet standards. You can see pins 1 and 2 on a network interface card are your transmit pairs, and if you're looking at a network switch, pins 1 and 2 are the receive pairs, and we're running straight through from transmit to receive for those 2 devices. The straight-through cable is a little different when you look at gigabit Ethernet, which is 1000 base T. This straight-through cable is going to use all 4 pairs inside of the cable. And you'll also notice there's no dedicated transmit and receive pairs. Instead, you're able to both send and receive traffic through a 1000 base T connection on the same wires at the same time. This is a lot different than dedicating a transmit and receive, and instead we're able to send traffic in both directions simultaneously. If you need to connect like devices to each other, you would not use a straight-through cable. In those cases, you would use a crossover cable. So if you're connecting a workstation to a workstation, you need a crossover. If you're connecting a switch to a switch, you need a crossover cable. You can see the pinouts on a crossover cable are a lot different than a straight through. We're no longer going from pin 1 to pin 1. We'll go from pin 1 to pin 3 and pin 2 to pin 6 and so on. If you are connecting like equipment to each other, You may find that you don't need to perform the crossover inside of the cable. Instead, you can perform the crossover inside of the device that you happen to be using. This is called auto MDIX, and this is something very common on the Ethernet cards inside of your workstations, your servers, your routers, and all other Ethernet devices. The device will examine the incoming signal and make a determination on whether it should act as a straight-through signal or as a crossover, and it will make that change in the Ethernet card itself. One thing you'll notice with this crossover cable is that one side of this is not 568A and the other side of this 568B. Ethernet crossover does not deal with 568B or 568A standards. The Ethernet crossover is something very specific to the way Ethernet connects to each other, and it's not related to a termination standard. Visually, for 10 megabit and 100 megabit Ethernet, where we're using 2-pair, this is the way the crossover cable would look, where we're going from pin 1 to pin 3 and pin 2 to pin 6. If we look at an Ethernet crossover cable for 1000 base T or gigabit Ethernet, you can see that we maintain the pin 1 to pin 3 and pin 2 to pin 6 so that we have backwards compatibility, but you can see we're also crossing over pins 4 and 5 and pins 7 and 8.